Good day to Mr. Padma and my fellow classmates. Today our group, which consists of Pizon, Yvonne, Chin Weng, me, Chunket, and Chunhao, will be doing a video about physics investigation on question 2. In this video, we're gonna look at the working principle of an AC generator. Next, we will talk about the flux versus time and magnetic versus time graphs, which obtained from an AC generator, and then about mathematical equation which related to EMF. After that, we will talk about what is back EMF in a motor. We are also gonna look at how industries convert mechanical energy to electrical energy, and also what have been done to increase the efficiency of those AC generators.
The working principle of an AC generator in relation to Faraday's law and Lenz's law. Faraday's law states that the EMF is also given by the rate of change of magnetic flux. The direction of electromotive force is given by Lenz's law, and that's how you get the negative in the equation. From the equation, we know that the EMF induced is directly proportional to the rate of change of magnetic flux. Here is an AC generator. By remembering Faraday's law, we know that EMF will only be induced when there is a change in magnetic flux linked to the coil. As you can see in the diagram, there are currently 6 flux lines passing through the coil. The number of flux lines are neither increasing nor decreasing. Therefore, it is constant at this position. Since magnetic flux is constant, there is no change in magnetic flux and no EMF is induced. Now let's see what happens when a coil is rotated in a clockwise direction. In this position, after we have rotated the handle or the generator in a clockwise direction, we see that there are 4 flux lines passing through the coil and 2 white lines that do not pass through the coil. What this means is now there is a rate of change in magnetic flux. Initially there were 6 lines passing through and now there are 4. So since magnetic flux has a rate of change, EMF is also induced and current flows through the generator. As we continue to rotate the generator, we see that there is a point where the coil is now parallel to the flux lines. Here, no lines are passing through the coil, thus magnetic flux linked to the coil becomes 0. Since initially there were 6 lines passing through, and now there are no lines passing through, the rate of change of magnetic flux is at its maximum. Therefore, induced EMF is also maximum. When we continue to rotate the generator, there is a point where the coil returns to the original position where there are 6 lines passing through the coil. The only difference here is that now AB is on top and CD is at the bottom, unlike in the beginning when CD was on top and AB is below. But regardless, all magnetic field lines still passes through the coil and the magnetic flux linked to the coil is constant again. So because of that, there is no rate of change of magnetic flux and no EMF is induced. Therefore, no current passes through the coil. As we can see in the galvanometer, there is no deflection. Now, as you continue to rotate our generator in the clockwise direction, we notice that there are 4 lines passing through the coil and 2 lines not in the coil. Now, since there is a change in magnetic flux lines, there is EMF induced in a generator. But notice something different here. The direction of the current induced in the generator is in opposite direction. This can be determined by using Fleming's right-hand rule, where with the thumb as the motion, the index finger as the direction of field lines, and the ring and the middle finger as the direction of current. So by using that, and also with the presence of slip rings in the generator, the current now flows in the opposite direction into the galvanometer. Similarly as before, there will be a time when the coil is parallel to the flux line, when no magnetic flux lines passes through the coil. So magnetic flux lines linked to the coil becomes zero, and the rate of change of magnetic flux becomes maximum again. Induced EMF is also maximum, but by this time, the direction of current produced is in the opposite direction. Since the current is alternating in different direction as we rotate the generator, we will produce an alternating current from the generator, which will be explained in the following slide.
So now let us look at flux versus time graph and EMF versus time graph which obtained from an AC generator. So the magnetic flux equation is given by Phi equals to B times A cos theta. B is actually the magnetic field. A is the area vector which points perpendicular to the coil, and theta is the angle between them. In the first picture, the area vector points to the right, which is perpendicular to the coil, and the amount of magnetic field flowing through the coil is at maximum. So the area vector here is parallel to the magnetic field, which the angle between them is 0 degree. So cos 0 degree is 1, so that the magnetic flux here will be at maximum. In the second picture, the area vector is actually perpendicular to the field. Field is flowing this way. So cos 90 degree is 0, so magnetic flux obtained here will be 0. In the third picture, the area vector is parallel to the magnetic field direction, but it is in opposite direction. This is magnetic field direction. Cos 100, so that the angle between them is 180 degree. Cos 180 degree is -1. And the amount of magnetic field flowing through the coil is maximum. So it will obtain a maximum negative flux. In the fourth picture, the area vector is again perpendicular to the field, and the field is flowing to the right side. And cos 90 is 0, and the flux obtained will also be 0. In the fifth picture, the amount of magnetic field flowing through the coil is at maximum. The direction of magnetic field is actually to the right also. And the area vector and the field are parallel to each other in the same direction. Cos 0 is 1, and flux obtained will be at maximum, which is same as the first one. So now let us look at EMF versus time graph. At the vertical position, the rate of change of magnetic flux is 0, and according to Faraday's law, the induced EMF will also be 0 at this point. So the first picture, the induced EMF is 0. As the coil starts to rotate clockwise, the rate of change of magnetic flux is increasing. And based on Faraday's law, the induced EMF will also increase and eventually reach the maximum point when it is in a horizontal position. So the second picture, the induced EMF will be maximum. When the coil rotates in the second quarter, the rate of change of magnetic flux is decreasing and EMF also decrease. It will then become zero when in vertical position, which is at here, the third picture. When the coil continues to rotate, the rate of change of magnetic flux increases and EMF increases, but it has a different polarity as compared to the first half cycle. The EMF here will reach the maximum negative value, which is here. The coil completes one cycle and it returns to vertical position. EMF is zero as rate of change of magnetic flux is zero. So the last picture, the EMF obtained will be zero.
After learning the working principle of an AC generator and also knowing about the graphs, let's learn more about the mathematical equation related to EMF of an AC generator. One of the formula that we'll learn today is the motional induced EMF at one side, which is EMF epsilon equals to B LV, whereby B is the magnetic field perpendicular to the motion, L is the length of the coil, and V is the velocity. Do take note of the terms here, such as the width of the coil, because we will be using this later in the next slide. From the formula before, we will substitute other equations into it, whereby EMF, the epsilon, equals to B, where B is substituted with E sine theta, and the velocity is substituted with omega times width over 2, where the omega is the angular velocity times the radius, which is the distance between the axis of rotation to the one side of one chord. From there, we can also simplify the equation to area because we have width times length here, so we can get an area here. And from there, we can get the equation B A omega sine theta over 2, which is this. After that, the net EMF that is flowing through the coils is 2 times. And if the coil has n turns, we will get this equation 2n times the EMF of one side. And after that, we will substitute this EMF at one side with the equation before, and we will get a general expression around a steady rotating multi-turn coil in a uniform magnetic field, and you will get this equation here. You can see that the theta is substituted with this formula, and to understand more, I also added this small point here. We can also change the equation to EMF times the maximum EMF times sine 2 pi frequency and time. This 2 pi frequency times time is also the angular velocity and time. Can recall back to the circular motion that we learned before, where velocity equals to 2 pi r over t, and the t, which is 1 over t, which is also frequency, and we can just get the formula 2 pi f. And from there, we will know that the EMF, the maximum EMF is 2 pi and VA and F.
Okay, next I'm going to talk about the back EMF. Motor has a coil turning inside magnetic field, and a coil turning inside magnetic field induces an EMF. This EMF refers to back EMF, sometimes called the counter EMF. Back EMF occurs when a motor acts as a generator, and a back EMF acts against the applied voltage, which means it reduces the current flowing. The applied voltage will cause current flow. That means it will experience a force, which means it starts to rotate. Therefore, the wire will experience a change in flux, and a change in flux will produce an opposing EMF or a back EMF. As the motor speed increases, the voltage increases, the current increases, therefore the rate of flux will change. Lastly, when load is applied, speed of motor decreases, causes the back EMF to reduce, hence the current in the motor increases.
Okay, now let us look at how electricity is produced by converting mechanical energy to electrical energy in hydropower station, and what have the people done to increase the efficiency in the industries. This is a simple dam structure diagram. Water flows into narrow penstock, and the moving water rotates the roller in the turbine. The turbine is here. This turbine is connected to an electromagnetic generator which can generate electricity. So the generator is here. The elevation created by the dam creates a gravitational force which can maximize the speed of water flowing, which is from high to low. As the water flows with gravitational force, the turbine is rotated and the coil rotates, which eventually generates electricity. The electricity is then stepped up by the step-up transformer, which is at here, and transmitted by the transmission tower for domestic use.
Here is a simple diagram of a wind turbine. Wind blowing the turbine can turn the blades and produce electricity from the generator attached in the wind turbine. The simple airfoil technology makes the wind turbine blades turn. That means there's a lift force produced when wind passes through the airfoil. So the lift force will push the wind turbines in this direction. So the turbine will rotate in the clockwise direction. The wind turbines typically turns at a very low rate of RPM, which cannot be used to produce much electricity from the generator. So the turbine is connected to a gearbox where the speed is increased. As you can see, the blades will rotate, for instance, in the clockwise direction into this at a very low RPM, which is then increased, the speed is increased in the gearbox over here. So the gearbox uses a very special set of arrangement to achieve a high speed ratio. Then the gearbox is connected to a generator where high speed rotation is converted into electricity, which then is stepped up by a transformer at the base of the wind turbine.